Hello and welcome to an overview of Ndt Care Vista software. The Ndt Care Vista gives a complete record of an entire, possibly very complex rope examination, including LMA, LF, and WRR signals, as well as inspection time, distance along rope, total length of rope inspected, rope speed, and start-stop operation. For example, this software can be used for monitoring the rope condition, distance and speed, and time during complex rope maneuvers like A&R operations of pipelay vessels, deep sea lifts, and combined visual and MRT inspections when the rope is stopped during an MRT inspection and moved back and forth for a visual examination. Shown in the video that follows are an experimental inspection performed on a test rope at NDT Technologies. Here, the ends of the rope are welded together to form an infinite loop. The rope is exactly 5 meters long. The weld shows clearly on the LMA-LF traces and can be used as a 5-meter distance marker. The second test case shown in the video is that of spooling of a 78mm A&R winch rope, which is 3.2 kilometers long. The inspection lasted about 10 hours with numerous lengthy stops for repositioning of the pipelay vessel and the supply barge. In this video, we're going to show you a new feature within NDT Care. This feature is referred to as Vista. One attribute of Vista is to try to replicate some of the data features that you would see in a SCADA system on various vessels. We can start by opening the file, and you'll see everything is the same as for Ndt Care 3.0, except we have this new Vista tab that we'll show in a second. So first we have to open a file. We'll select a text file type. The first file is our start-stop testing that was performed at our NDT facility. We'll click that and open. We'll ask if there is decimation. At this time I'll say no, it's a relatively small file, and you can see it's already opened. Then I'll go immediately to display LMA-LF charts. This particular inspection was just under 100 meters, so I will select 20 meters per tab, shown in a forward direction. We can then change the axis scaling, as we've shown in previous videos, and hit accept. Now you'll see that the Vista option is available, so we'll click on that. It will now ask for you to select an integer number of seconds of data to display per page. The file open in this case has 418 seconds. I will select 30 seconds per tab. The default access settings that were saved last time are inherited. I will just hit OK and accept the access settings. I will move the user interface to the background. So what you'll see is that we ran this for a little bit of time, and then we paused it for several seconds, ran it for a little bit more, paused it for more time, and then ran it again. So we can compare this with the distance plot. One of the things you'll see is we can start counting these lower tabs here, 1, 2, 3, 4, and 5. We can then go to the other plot, the distance plot, and what you'll see is the first 5, 1, 2, 3, 4, 5, and then you'll see the speed signal come back down to 0. So at this time of 0, notice what happens is we actually pause the system for quite some time. However, when we save the data file, we are not actively recording during that time. So what you'll see is the LMA and LF traces will remain constant for that time. I'll switch back here, and you can see that. Right when the speed signal drops to 0, the rope holds at that payout amount, and then we'll start again sometime later. You'll see the rope speed accelerate here from the right chart. We can also count the number of lower spikes here, 1, 2, 3, 4, 5, 6 within that range. Go back to the distance chart as shown here, and between these two sections you'll see 1, 2, 3, 4, 5, and 6 between that as well. Then we're stopping the rope during this time. From the distance charts, you'll see a very short amount of time before we continue on for the remainder of the lower spikes here. Going back to here, you can see we actually pause. So again, during these times, we are just holding, we're not actually saving data to the file. That helps with reading in of file sizes. And then the final number of inspections are shown here, and then we finally come to rest. Also, like we've done with other plots, is you can scan from a zooming perspective. So I'll look at the first 30 seconds. So again, you can see very good fidelity in here with the inspections, and that'll allow you to zoom. Notice in the next period here from 50 all the way to over 200, all of these inspections should basically just show the same constant value. We'll keep going, same values, and then finally at just over 200 seconds, 220 or so, 225, you'll see that the inspection starts up again right after roughly 230 seconds. Okay, so we can continue on with the zooming. You'll see it stops just to the right of 250 shown here, and then so on and so forth. So just around 400 we should see it starting up again, and then finally ending here. So now what Vista shows is our LMA in percent, our LF trace, and our rope payout here in blue as a function of actual time of the inspection, as well as the rope speed in meters per second. This, you'll see, we had up to 1.5 meters per second. Again, this was in our test lab where we had a pretty fast system that we have at our disposal. On most ships, this will probably be in the half meter per second or potentially even lower. Again, a final comparison to the distance plot. As you see here, you'll see the full inspection and the rope payout. This is the actual rope payout. This would this x-axis, distance meters, really is the total length of rope inspected. So in this case, we were not going in a reverse direction. However, if you were to see a negative speed here, you would see that this rope payout would actually come back down. For example, you're reeling in some of the rope, and then you might roll it back out again. So again, on the x-axis, that would be the total distance of the rope inspected, whereas the x-axis would be essentially the rope payout, similar to what you might see again at a SCADA system, as well as the rope speed. So all in one, we have captured either as a function of inspected distance, or shown here, the actual time stamps relative to the full inspection. So you could have either way, the flexibility for your inspection, whatever works best for you. Bringing our graphical user interface back to the front, I would like to show another file inspection. I will open a file, text file as well, and this time we will look at this example AR rope file. Now what you can see here, it's a pretty large file, just under 2 gigabytes. As I open this will take a little bit of time to open. I will do a decimation by a factor of 16. So within Vista, you can also do the decimation. Because it's such a large file, I will choose this large decimation factor. It will take a little bit of time to load. Real quick, a overview of this rope is this was a spooling of a 76 millimeter A&R winch rope on a pipelay vessel. The file has been opened, as you can see, it's been decimated by that factor of 16. I will then go to display the LMA LF charts. Notice again that this rope is over 3 kilometers long, so I will choose to look at this in 100 meter long segments. I will look at this in a forward direction, and I will adjust the axis settings. And I will accept the axis settings. I will now go to the Vista plots. Note that this inspection was just under 36,000 seconds, which would equate to roughly 10 hours. I will select 1800 seconds or a half hour per tab for my inspection zooming. As you can see, the Vista plot shows up. There are a few little discontinuities in the plots. Anytime that you see a start or a stop right in here, there is a spike associated with the speed signal. We could look in the range here of maybe just after 1500 here, where you'll see some stopping. So I can click on that tab. Again, a lot of data to be shown. It might take a second or two to switch over. And here you'll see. So I actually, good data in here that we can see. And then maybe shoot over one, and you can see that's where it stops. So again, you can see these spikes here in the rope speed where the process stopped. And so again, there's some filtering we'll fine tune over time. And also there is some data missing here. You can see the actual rope speed here is 1.5. So again, this rope, unlike the previous test we showed, is probably only about 0.2 meters per second. I wanted to keep this same scaling compared to the one that we did at our test facility, just to again show you that typically on vessels the rope speed is much slower. Okay, and again, the missing data here is only due to the fact of I'm pretty much out of memory here, so I just wanted to show you that. Again, we could keep scrolling or again show the overview plot here. And again, what you'll see is it looked like we started and then immediately stopped again, so that's why you'll see this relative to the rope, and then we started up again. You'll see here we stopped. So again, it's anytime we do a start or stop function that we're seeing these little spikes here on the rope speed. So again, if you can just look through there, then you can actually see the actual system is actually performing quite well. So again, here is the actual, as a function of distance, if you look on the x-axis. And then again, the actual time that was spent doing the analysis. Again, that, for example, something that you might actually see relative to the SCADA system that we have. So that'll conclude this video showing you some of the early demonstrations of our Vista development. And if you have any questions on this, please don't hesitate to reach out. Thank you very much.